Another hello from West Virginia. Eventually. So, joke of the day, that's now. And are you ready? I know you are. What did the marker say to the pencil? You are looking sharp. And the other thing that looks sharp is the ability to rationalize the denominator by using a conjugate. Now, like I said before, we had some fairly sort of kind of simple fairly simple denominators, because in the previous examples in the previous video, those denominators only had one term in them, like maybe just a square root of 7 or just a square root of 3. Notice that these denominators, oh my gosh, they're pretty complicated. I've got a 3 plus a square root of 7, 2 plus a square root of 3. Square root of 5 minus square root of 2, 2 square root of 3 minus square root of 7. These are complicated denominators because we have a couple of terms in them. Now, when that happens, take a look at a situation here. If I was to continue to rationalize the way I have always been rationalizing, in other words, let's just multiply that denominator by a square root of 7, notice that when I multiply it here, it's going to be great, because the square root of 7 times the square root of 7 is going to be a square root of 49, which is 7. In other words, when I multiply a radical by itself, I get the number underneath the radical. That's going to be great. But the problem is, I don't just multiply square root of 7 to square root of 7, I multiply square root of 7 to the entire denominator. So when I multiply it here, I'm going to get a 3 square root of 7. Notice that I have retained a radical in the denominator. So our previous processes are not going to work. I'm going to need something a little bit bigger than this. This is where the idea of that conjugate comes in. A conjugate is two algebraic expressions that have a sum and difference of the same two terms. We saw this before whenever we had complex conjugates, and we had the sum and the difference of the same two terms that had an I in it. Notice here that the square root of A plus the square root of B and the square root of A minus the square root of B are conjugates. We have the same two terms, square root of A, square root of B. The only difference is the sign that's between them. That is what makes a conjugate. But the beauty of conjugates is what happens when you multiply them. Notice we've got a couple of conjugates that are being multiplied here. And if you didn't even have a radical in it, and it was A plus B, A minus B, you would FOIL it. Well, you're still going to FOIL it. Nothing changes there. And when I FOIL this, I'm going to multiply square root of A times square root of A. And you know that that's going to be square root of A squared, which is just an A. Square root of A squared, which is just an A. In other words, when you multiply a radical by itself, you get the number that's underneath the radical without the radical sign. But now I'm going to multiply that square root of A to the back here. Positive times negative is negative, and a square root of A times a square root of B is just simply a square root of AB. Nothing real exciting there. But now I'm going to pick up this next guy. I'm going to distribute him through, and the square root of B times the square root of A, notice positive times positive is positive, and I get square root of B times square root of A. Well, that's just another square root of AB. Nothing real exciting. But notice what happens here. Yes, these two are going to cancel each other out completely. Now notice I'm not done FOILing. I'm going to take that square root of B and multiply it here in the back. Positive times negative is negative, and square root of B times another square root of B, like we said, is going to be a square root of B squared. And what's a square root of B squared? Just a B. Like we said before, when you multiply a radical by itself, you get the number underneath the radical without the radical sign. But the important thing is, what do you notice? Oh yeah, the radical's gone. So multiplying conjugates gets rid of radicals. It is a beautiful thing because I don't want radicals in the denominator. And when I have complicated denominators that look like this or this, the way to get rid of it, the way to rationalize that denominator is to multiply by the conjugate of that denominator. So let's go back to these examples that I had before. So in that first one, instead of multiplying by just simply a square root of 7, because as we noticed, that's not going to get rid of that radical in the denominator. Instead, I'm going to multiply by the conjugate of that denominator. Now, what's the conjugate of 3 plus the square root of 7? Remember, conjugates have the same two terms. The only difference is the sign that's between them. So now I'm going to FOIL that, and when I do, I'll get 3 times 3 is 9. And on the outside here, positive times negative is negative, and 3 times the square root of 7 is just a 3 square root of 7. Now on the inside, I get positive times positive is positive, and 3 times the square root of 7 is 3 square root of 7. And like we had seen before, these are going to cancel. Same two terms, opposite signs, they're going to cancel. And now I'm going to finish out my FOIL with positive square root of 7 times negative square root of 7. Positive times negative is negative. And like we said before, when you multiply a radical by itself, you get the number underneath the radical without the radical sign. So what I have now in that denominator is just a 9 minus 7, which is just a 2. Ta-da! Radicals out of the denominator. But you know that what you multiply on the denominator, you have to multiply up on that numerator. The beauty is this is just 1 times that. So 1 times anything is just itself. And I'm going to carry that 3 minus the square root of 7 all the way across. And like we said before, if I can divide the 2, we didn't say this before, but if I can divide the 2 into each of these terms, go for it. But I cannot divide that 2 into both of those terms. I can't divide it into either term. So this is as good as that one's going to get. All right, let's try a couple more just to make sure we're really good at this. So like we said before, just simply multiplying by square root of 3 is not going to fix this. So I'm going to multiply by its conjugate, and the conjugate is going to be the same two terms, just a different sign between them. So instead of 2 plus the square root of 3, it's going to be 2 minus the square root of 3. And when I FOIL that, 2 times 2 is 4. On the outside, I'm going to get a minus 2 square root of 3. On the inside, I'm going to get a plus 2 square root of 3. And in the back, I'm going to get a positive times negative is negative. And square root of 3 times square root of 3, when I multiply a radical by itself, I get the number underneath the radical without the radical sign. And like we saw before, yep, these are going to cancel. So I am left with, in that denominator, just a 4 minus 3, which is just a 1. Now, like we said before, what you multiply on a denominator, you have got to multiply on that numerator. And so now, once again, 1 times anything is just itself. So I'm going to carry that 2 minus the square root of 3 all the way across. But the cool thing is here, when a 1 is in the denominator, you don't have to show that. So it's just a 2 minus the square root of 3. End of story. It is simplified. The radical is out of the denominator. Notice in both of these cases, it's okay to have a radical in the numerator. No big deal. You don't want a radical in the denominator. So that's how we got rid of it. So now let's take a look at these last two that are a little bit more complicated. Once again, I need to multiply by that conjugate. The conjugate of square root of 5 minus the square root of 2 is going to be the same two terms, square root of 5, square root of 2, but change the sign between them and make it a plus square root of 2. So now when I go to FOIL, here's where it's going to go crazy. Square root of 5 times square root of 5, remember, radical times itself is going to be the number underneath the radical without the radical sign, because this is really square root of 5 times 5 is 25, and the square root of 25 is just a 5. Now on the outside, I'm going to get positive times positive is positive, positive square root of 5 times square root of 2. And on the inside, I'm going to get negative times positive is negative, and once again, square root of 5 times square root of 2. And again, they're going to cancel. Hopefully you guys are noticing a shortcut that you can take. When you multiply conjugates, the outsides and insides are always going to cancel every single time. So the shortcut that you can take is you can just simply multiply the front 2 and the back 2. And don't worry about the outsides and insides. You know they're going to cancel, so don't worry about it. So in the back, negative times positive is negative, and once again, square root of 2 times square root of 2 is just a 2. And now in that denominator, what you really have is just a 5 minus 2, which is just a 3. But what I multiplied on a denominator, I have got to multiply on a numerator. Now, there's a couple of ways of handling this multiplication that's up here. I can take that 3 that's being distributed through this parentheses, and I can go ahead and distribute it through. And I can get a 3 square root of 5 plus a 3 square root of 2. Now if I do it that way, once again remember that this denominator has got to divide into both of those terms in the numerator. If it won't divide into both of those terms, I can't do it. But the nice thing is the 3 will cancel out with this 3. It will also cancel out with that 3, leaving me with a square root of 5 plus a square root of 2. And like I said before, it's okay to have a radical in the numerator, just no radical in the denominator. That's not cool. But you don't have to distribute, because check this out. If I keep it like this, and I just simply keep it as 3 times square root of 5 plus the square root of 2, notice that, remember that quotient rule that says if they're both under a radical, I can go ahead and divide. But if they're not both under the radical, I can't do that. So notice what happens out here is, oh, these 3's will cancel, once again leaving me with square root of 5 plus the square root of 2. So it works. And like I said, either way is okay. You can distribute through, but if you do, make sure that this will divide into both of those terms. If it won't divide into both, don't do it. Or just leave that term, that factor on the outside and cancel on the outside, which is what most people prefer because it's a little bit easier, prevents you from making mistakes because you're going to simplify a fraction. So let's take a look at this last example and go with what we just said. All right, I have got to multiply by that conjugate in the denominator. The conjugate of 2 square root of 3 minus 7 is 2 square root of 3 plus the square root of 7. Same two terms, just change the sign between them. And when I FOIL, now here's where you got to be careful, folks. When you multiply 2 square root of 3 times 2 square root of 3, be careful about this. 2 square root of 3 times a 2 square root of 3. I have got 4 factors that I'm multiplying together. It is a 2 times the square root of 3 times a 2 times the square root of 3. So I can multiply those 2's together, and I can multiply the square root of 3's together. Now, 2 times 2 is 4, square root of 3 times square root of 3 is 3, and 4 times 3 is 12. You've got to be very, very careful about that. You are multiplying 4 factors together, because what a lot of people will do is they'll multiply 2 times 2 and get a 4 and call it 4 square root of 3. Or the other thing that people will do is they'll multiply square root of 3 times square root of 3 to get a 3, and then they'll just do 2 times 3 and get a 6. But you've got 4 factors there. You've got to multiply all 4 of them together. Now remember, outsides and insides are going to cancel because they're conjugates. So now I'm only worried about the back. And minus square root of 7 times plus square root of 7, positive times negative is negative, and square root of 7 times square root of 7 is square root of 49, and the square root of 49 is 7. Remember, when you multiply a radical by itself, you get the number underneath the radical without the radical sign. And 12 minus 7 is 5. What I multiplied on a denominator, I have got to multiply up on that numerator. So I'm going to multiply that 2 square root of 3 plus the square root of 7 up on that numerator. But remember, I can either distribute the 10 through, but I personally think it's a whole lot easier just to let it sit on the outside and cancel on the outside. So that 10 is going to stay on the outside to make my life a whole lot easier, because notice here, on this outside, 5 and 10 will cancel. 5 goes into 5 once and into 10 twice. So what that leaves me with is, once again, a 1 on the denominator, which I don't need to show, but on that numerator, I've got 2 times 2 square root of 3 plus the square root of 7. Now at this point, it depends on your instructor and your textbook as to whether they'll leave this alone and let you keep the parentheses in there. I was always taught it is not simplified if there's a parentheses in there. I was always taught distribute that 2 through, and 2 times 2 will give me 4. So I have 4 square root of 3 plus 2 square root of 7. I was always taught keep on going and get rid of the parentheses. But if your instructor, if your textbook will let you keep the parentheses, then this is going to be perfectly fine. But I hope this helps with using those conjugates to get rid of radicals in the denominator when you've got more complicated denominators like you see right here. And remember, a conjugate is the exact same 2 terms. The only difference is the sign between them. I hope it helps. Have a great day.